thank ARC and Greg for giving me the opportunity to talk about what my company's been doing. We had a project for about the last year and a half, which is been pretty exciting for me, and it's interesting to follow on after the last speaker. They build cars. My company, we recycle cars. There's a kind of end of life. I'll quickly go over the history of my company, and then I'm going to talk about the problem we had, or what the products that we manufacture, the problems we were trying to solve, and the technology we used. The technology that we used, in this instance, actually became an enabler. At the same time, it created challenges which we didn't foresee, and hopefully this is something which should be of interest, because technologies that are available today really do allow us to do things that we really couldn't do before. Before I go through this, I did give a presentation a few months ago internally. It was at a regional conference, and I went through some similar slides. There was a lot of animation, a lot of crosstalk going on between the operations folks and the senior management. At one point, senior management saying, "We have tons of data. Why do you guys need more data?" An operations analyst on the other side said, "We have tons of data. We have no information." And everything that I've heard in this conference, in the other speakers, is exactly that. It's about turning data into actionable information. So go back to the history of a company. Schnitzer, in 1906, formed the company. It's the Alaskan Junk Company, with material he brought back from Alaska. In 1946, he turned it over to his 5 sons. And then in 1952, sadly, he died. However, at that point, the sons took the company and they really expanded it. And they moved into shipping. They built Liberty ships. They did real estate, and they went into rail cars as well. At that point, in 1984, we acquired our first foundry. We have an electric arc furnace, which is a cascade steelling rolls. So we started to become vertically integrated. And it gave us a source whereby our scrap metal that we recovered, we could turn it into rebar and other secondary products. Then in 1989, we entered into pick and pull, again, vertically integrated. Now, these are the places where end-of-life vehicles will come in. They'll be depolluted. You can have it where people can pick up parts, but eventually they become the feeder yards into our shredding processes. 1993 became publicly traded. 2006, we're suddenly at revenues of $1.85 billion. 2007, we're up to $2.5 billion, and we're joining the Fortune 1000 company. 2008, $3.64 billion. And in 2010, we went international, moving into Canada. Significant, publicly traded. Obviously, we got the money. We went into acquisitions. And really what's happened in the scrap metal business is it used to be a lot of mom and pop shops. Well, now we have it where we acquire them, and we can start to develop processes, economies of scale. So we're divided into 3 major parts. The most significant one, primarily, is our metals recycling business, and that's the collection and processing of scrap metal. Our order part business, the pick and pull, and then the steel manufacturing. One of the things, as you see here, we do have most of our shredding facilities are on the west and east coast, and it means that we can shred. We can bring material in, we can shred it, we can go out to the export markets on the west coast and on the east coast. From the east coast, predominantly Turkey. Track record of growth, we've got about 117 facilities now. As I say, we are expanding into British Columbia and Canada. And we've gone, since 2005, from 1,800 employees to 3,600, from 41 facilities to 121, and revenues have increased from 853 to 3.3 billion. So it's been significant expansion. So really, we have 9 facilities that do our shredding. We call them S&P, shredder, and port facilities. We will take in end-of-life vehicles, peddler scrap, light iron, tins, goods. Down in the left-hand corner, this is a shredder. This is a, I'm not sure what this one, it could be a Texas mega shredder, 9,000 horsepower. In the bottom right-hand corner is the rotor. So it's 133,000 pounds. It has 16,000-pound hammers attached to it, rotates 450 RPM, beats the living tar out of the cars. So we put in a car 7 seconds later. You end up with Actually, that's the inside of it. You end up with, that's what the car looks like at the end. And we can process 260 tons an hour with these things. Down there, that's just a model of the inside of one. It's like a cheese grater. I mean, really, there's nothing technical about it. It's sheer brute force. So getting the ferrous portion out is easy. We use a series of magnets, cleaning magnets, polishing magnets. We can get a nice, clean scrap ferrous metal, and that will go off to go in as a feedstock into electric arc furnaces. Where it gets trickier is in the non-ferrous metal separation, because now we're not just dealing with a ferrous metal, we're dealing with brass, copper, stainless steel, aluminum, insulated copper wire, and a lot of different alloys. So one of the things that's been so interesting over the last, I would say, 3 to 4 years has been the advancement of technology into essentially what was a scrapyard. Call it a junkyard. We've now got XRF, X-ray fluorescence. We're using induction sensor sorters, eddy current separators. We're using density separation, classifying, screening. And basically, this is mining. It's modern mining. They said the biggest growth field is in urban mining. They're opening up landfills because material that we used to throw away, we now have the technologies that will enable us to get this out. Challenge is, you're trying to implement this kind of technology into a scrapyard. This is a place where we don't even like to pay to put down concrete. We want to buy scrap. We want to sell scrap. So what's the challenge? You know, okay, it is a scrapyard. And I've said, you know, there are technologies getting greater there. We used to use eddy current seppers, and people pick out material by hand. But if you think about it, we buy scrap, we sell scrap, which means that we don't exactly know what it is we're buying, and we don't exactly know what it is we're making unless we sample. It's a pretty complex problem. And when you compare this to normal mining, you know, if you look at a molybdenum mine, you're trying to get molybdenite out, one thing from 6 things. So you've got granite, feldspar, quartz, and probably lead in there. There's one thing from 6 things. In the scrap metal recycling, we're trying to get 10 things out of who knows how many. And when you think of all the different types of alloys, it becomes a tricky problem. I put this up here. We have names of our products. We call it Zorba. Zorba finds meatballs, Zebet, Ocean, Torque, Twitch. They're all code names. In the days when this stuff would be put in the back of a container, you didn't want people to know what was in that container for fear that it didn't actually quite make it to the port. So I want to step back here. And this is a picture of a semiconductor fab. My background was automation, process control, and robotics in the semiconductor industry, and I worked there for 15 years. I think this is Boise, or no, Micron in Boise, Idaho. And here, obviously, a lot of complex process equipment and metrology equipment. We had strangely lit rooms, and to be able to control, you know, a plant like this, we had advanced process and control, statistical process control systems to enable the whole thing to come together. And then in 2009, I became a plant manager in a scrapyard. That was my plant. That was my control panel. That was my controls. I was like, whew. So with the background and coming in, so we can do better. We can do much better here. So when we look here, saying, what is a problem? Well, we've got a system here, conveyors, eddy currents, and we were starting to get in these induction sensor sorters, which are getting complex piece of equipment. We've got no fault monitoring. I would come in, why were we down for 6 hours? Well, you know, a tail pulley got plugged up, material dumped, and the first time anybody knew anything was when no material was coming on a belt. By the time they found it, 6 hours of digging out. You know, come on, this is ridiculous. There's tools we can use. We had no real-time collection of data. So when I'm looking at continuous improvement, what's my top 10 downtime, what's my Pareto analysis, it's what's been written down on a piece of paper. We spent more time collecting the data, writing the data, putting it into a spreadsheet. You know, there's better ways. We had no real production analysis. As I said, we don't know what we're buying. So we're always looking at what's the yield, what's the recovery of the material we're buying. Great information for our commercial team. If they know what they're buying, or the recoveries of what they're buying, we'll say, don't know what you're buying, but buy more of it. Or whatever you just bought, we don't want any more of that. But there was such a lag, we didn't really have the data going into the systems. We just buy it. We know when we're happy when we're making money, we're not happy when we're not. And you've got information stored across disparate data sources. We've got our ERP systems and our CRM systems and our inventory systems, but we've got nothing for production. So if you want to kind of do any analysis of how well are we doing, can we do better, it's like, give me 3 hours, and I'm going to pull reports, and I'm going to come up with something. And I used to go to his meetings. I could be saying, my yield is 11% last month, and somebody else was saying, oh, well, looking in my data, you're only at 8%. We all had different numbers. If I wanted to justify a project, my numbers look terrible. I need justification to get it. If it's for my bonus, numbers look great. It's spreadsheets. I mean, whatever you do, we're all looking at different data. And the information wasn't easily accessible. So you think about parts. You want the part, who needs the parts data? People who are going to be changing parts. Well, they were the union labor. They don't have access to the computers. They don't have it. So you could look at the anatomy of a breakdown. 2 hours of wandering for a part, looking for a part. So really, at the end of the day, just drove. We had no real actionable information. Well, since that day, we have come a long way. We've invested a lot of money in state-of-the-art technologies that allow us to extract more and more. We can pick out insulated copper wire from a stream of material. And we put in control panels that actually allow us to monitor and record the systems. And we started to create screens that's got automated sequence startups and an analysis of data. What's the quality of our products? What's the loss to a landfill material? So when we did this one, and one of the nice things here is that we didn't have a legacy system, at least not for our production control. So we could start, carte blanche, white sheet of paper. And we used a third party, our systems integrator. So we came in, Allen Bradley PLC, E3 relays. We've got the process equipment in there. We're using Ethernet connections to it. And then they put in 4 HMIs. And they're using RSView Studio. So it's thinking, yeah, fantastic. Now I've actually got a control system. I can do sequence startup, shutdown. I can do fault monitoring. I can shut down the plant if I see if there's a problem. And we did see significant gains or reductions in the downtime. The problem we had is that we didn't have a process historian. We had no historical data collection, so if a motor did fault out, we couldn't go back and see what just happened in the last few minutes or seconds. No real analysis capability. We had those sensor sorters. They've got a $100,000 sensor bar inside them. They can produce an incredible amount of data. It would be fantastic. It would actually tell us how much metal we're seeing going across a belt. But we had no access, and there was no good way to go from this PLC to talk to another OPC device unless I put in an OPC bridge connector, and then I had to get another computer and another one, and suddenly my system's starting to get less reliable. And we had limited users. We had 4 HMIs, so there was VNC on there. The ops manager could have a look on the screen, but then you could only have 4 remote users connecting. And quite frankly, it's a security. There's no authorization. There's no authentication. They take over the role of whoever's logged in. So it's just not a good solution. We had our next project, which was adding significantly more equipment. And this time, we're looking for a solution to address these. And we want a manufacturing execution system. Now we want something that's really starting to say, when are we going to schedule production? When are we going to schedule down, maintenance? And then what's my availability numbers looking like? So this is when we evaluated a number of different solutions, and we settled on using Ignition. And the reason we settled on Ignition was that this actually gave us the ability to have a platform that gave me multiple solutions at the same time. I could justify it by saying, we're going to use OEE, lean manufacturing standard, commercial off-the-shelf software we can buy, but it's also an HMI solution. So now I can actually upgrade my HMIs, and I can do some pretty slick stuff. So now we're starting to write jet tests. I can connect to the process equipment because the Ignition also has an OPC connection. So it will communicate to any OPC device. So now we'll put on here a jet test. That during maintenance, they can click a button. It will cycle through every single valve, and we have about 2,000 valves. And it can also read from our OPC pressure and flow switches, and then just give us a visual. Nice software for that. So I can do my HMS, I can do my MES, my HMI, my MES, and it's also a SCADA solution. So we started to whip out screens. And it gave us, say, production scheduling, the real-time, downtime, Pareto analysis. A process historian was built in that we used through SQL. And the business model, unlimited access through web-based clients. So I'm now not limited to just 4. Anyone in the organization, anyone. I can go to anyone's computer anywhere. So I can be in Boston with the president of a company, and I say, have a look at what we've done. And he says, well, how do I connect? And I say, log in. It's done through LDAP. So he logs in with his username and password. He can view the plant. He can't actually do any control. Everything is role-based. The trouble is, this is great information, but we're missing one part. You know, we're not connected to any of the other information systems. And when I started to roll this out, I'm no longer the operations manager there. The guy who's taken over, he looks at this and he said, you know, the system's fantastic. You know, what it can do is great. But he said, but I'm not just managing production. As a manager, I have to manage my costs. I have to manage my inventory. I have to manage my parts. I've got to manage my labor. These are all the things. And although this can give me all the data about production in one place, I've still got to go to Oracle. I mean, I've still got to run a crystal report. I mean, I've still got to go here, and I've still got to pull all the information together. So the next project that we had out was to satisfy this. And again, still using the gateway server, and we could have kept one, but now we're rolling this out to a number of our sites. So we're going to put it into Surrey in British Columbia. We're putting it down in Oakland as we speak. We're putting it into our Everett plant. And then we said, let's create a central server, one that can actually interface and connect, because it has ODBC connectors to any other system there. So we can start to consume data. We can pull it from these different systems. And what it allowed us to do is get an integrated view of all the manufacturing data, turn that into actionable information. So instead of just looking at my costs, I can look at my costs and say, this is how much it cost, this is how much I produced, this is how much I cost, this is how many run hours I had on a piece of equipment. And you can start to break it down. You can start to say, what's the run cost of this piece of equipment? It may keep breaking down, it may be expensive to run, but it pays for itself compared to a piece of equipment that doesn't really cost that much, but is never actually available for us to use. And it's bidirectional. It now allows business information to flow down to the manufacturing, and manufacturing to flow up, because we're putting the data, production data into the system, and it can bubble up. And I remember I read a while ago an article about, I think it was from Maverick Technologies, which really struck a chord with me. It talked about you're agile or you're dead. And they talked exactly about this, that quite frankly, you know, business intelligence will tell you this is my sales, this is my revenue, and this is my costs. But manufacturing intelligence is about how much is it costing me to make this product? Am I making the right product? Am I using the right process for this product? And it's a different view. You get this information to the people who need it. You don't want the data just go all the way up. So now we have a system that I say it's web accessible to every level of the enterprise. But now it's caused challenges. Challenges in a different way. Technology's enabled us. And the problem we're having here is who owns the data? Who maintains the system? Yeah, who controls access to the data? Who's going to validate the data integrity? If we're pulling data out of our EAM system, our inventory, and reports are being generated, people are nervous. They're nervous that you're going to get a different set of data or results compared to where you look at it. And because now we're transcending a boundary between automation and control of the plant floor to what is predominantly IT and the financial systems and pulling that data, we now have to fall under IT production control, change control, IT general controls, and then SOX compliance. We may not be a SOX system or considered an in-scope system, but it doesn't matter. As far as IT is concerned, we have the same set of controls. So now then we start to talk about separation of duties, i.e. as a developer, I can make a change in the development environment, but I can't go anywhere near a production system. And there's all good reasons for why we have these controls in place, but they were generally for the financial reporting of a system. And what's happening now is that as this technology has enabled us to use the same development environment for our HMIs, for our controls, to our manufacturing execution system, to our enterprise manufacturing intelligence, we're starting to find that the same controls are in place. So where does it stop? You know, changes to the PLC code, changes to the HMI. we're going to have to set up. And these are the things that we're working through as we speak. So what I put down there, agile, well, almost. I've found this technology is probably by far the most productive, efficient software that I've ever used in 15 to 20 years of software development. And it's suddenly, there was that buzzword of agile. Agile project management, agile development, extreme programming. That's probably about 7 or 8 years ago. Well, this technology allows it. I don't need to write requirements or use Visio to create use cases or software. I can just whip out a screen in minutes and then show the guys and say, what do you think about it? So it's agile, but it's now the systems that we've actually put in place that prevent the agility to roll out these changes. So it really started to make me think about, what's going on here. I'm really surprised that I guess I didn't expect the challenges that I'm facing. And I started to think about the traditional technology group divisions. So this is from my perspective for the companies I work for, that we seem to normally have 3 groups. We have the electrical controls group, predominantly electricians, controls, plant engineers, and their thing was the PLCs. They wrote in ladder logic. They were electricians. They didn't know how to program in object-oriented programming languages, so they stuck with what they knew. And they did the HMI development and proprietary process historians. And I worked in the software development groups, and we were software engineers. We were computer science graduates. We talked about object-oriented programming. We talked about DCOM, marshalling, multi-threaded applications, abstract, friendly classes. And the only time we really had any contact with the electrical controls group was once a year. The electricians would get together. They put a proposal to executive management saying, you don't need the software guys. We can do this with PLCs. We can do it with Wonderware. We can make it much more robust. You don't have to worry about blue screen of death anymore. And every year, the software group would say, knock yourselves out. I'd like to see you do recipe management. I'd like to see you do a 6GM interface with a ladder logic. On the other side, we have the IT group, predominantly BSAs, network engineers, IT admins, and they took care of network architecture, DBMS, CRM, ERPs, and they were SQL people. And the only interaction we really had between these 2 groups was every now and again when the IT group rolled out a group policy update that would stomp on our development environment. And it was like, guys, knock it off, Well, now the technology we're using transcends all of these 3 divisions. Because we've got a software here where my controls engineer, he's writing the HMIs and he's doing it. He's doing it Ignition, and he's doing it with Python scripting, Java modules in the background, and he's doing SQL queries. The same as what we're doing. So the technologies that have predominantly been with the IT group no longer remain there. And this one here was basically saying, this is, it's a great solution, but it's caused a problem. The problem has been because we no longer have these barriers. The technology transcends across controls, software, and IT. We've got an object-oriented development environment. We've got a rich component library. It's extensible through Java. We can do Python scripting. If you want, you can do SQL queries. But there's no proprietary language to learn. It was one of the things I was thinking about is when we looked at OEE, we could have bought a commercial off-the-shelf software. Or we could have written it in-house. Those have tended to be the 2 options we have. Or you can do both. And that's what we got with Ignition. We got something that, this is an OEE, it's a maintenance module, it's OPC compliant, it will talk to anything with OPC, it will talk to any database out there, but it's a development environment. So I can create anything I want to, and if I don't like the solutions that Inductive's giving us, it's source. I can make the changes to it. So what we're doing now is we're rolling this out and we're training our operations analysts and other people who are fantastic with Excel and saying, use this tool, because you don't have to develop. You can grab a control, stick it on a screen, do a SQL query, or tie it to a tag. And then when they're happy with it, they publish it. And that's it. Every user out there is now using this software and the change. And you go home to bed. You don't need test engineers, installation engineers. You don't have to compile it. You don't have to test it against Windows XP, Windows 7, or whatever. So, as I say, to my mind, I've never been so productive in my entire life. And everything that I've done is myself and my controls engineer, 2 guys. So in terms of information-driven production, how is it being used, what we've done? Well, the nice thing is we're all looking at the same data, but we're looking at it in a slightly different way. So we have the plant supervisor who's doing production scheduling. He can do the maintenance planning, Pareto analysis, and he's using that for continuous improvement. Changes to the PM, engineering modifications. The plant operator, he's the one who's controlling the plant. He's looking at the production runs. He's doing the process monitoring, condition-based monitoring. And the plant manager, he's looking at the OE analysis screens, the product quality, the utilization capacity planning. On the other side, we've been able to now, in a scrapyard, hire degree people, biochemists, to run our sampling program. So they're now looking at the sampling data. And they can take that data, they can tie it to production, and we can start to see exactly where the metals are in our streams. And we're using this data to change the processes we have today. And then the maintenance personnel are now able to pull it. Because we were able to pull data from our enterprise asset management, simplest change, we took the parts list in EAM, we pull it through. When a piece of equipment breaks down, they click on that motor faceplate, they click on a button, it shows them the parts list, description, part number, where it's located, and the on-hand inventory. It seemed like a small, insignificant part, but it was huge. These were the guys who didn't have access. They didn't have access to Oracle. They spent wandering around trying to find these parts. We can also now include in there, they can see the work order history. So they can see who worked on it the last time, how many times have we changed the same part. It's all about the actionable information, getting the data from the other systems to the people who need it. It's no good missing the data, but it does the maintenance personnel a heck of a lot of good. So thank you for your time.